Good morning, my YouTube viewers. Crystal here. I wanted to make you another video, but I'm having to make the video on NB Viewer. And the reason why is because I couldn't get the video to come up on my GitHub account, or I couldn't get the program to come up on my GitHub account because there's like a glitch in Chrome where GitHub won't show the programs, and there's also a glitch in Chrome where you can't download CSV files. So we always have to come up with ways that we can work around this glitch in Chrome. So after my birthday, a birthday present to myself is going to be a new Windows-based computer to see if I can work around a lot of these problems. The Windows-based computer I have at the moment is almost 7 years old, and it's really old and really slow. What I wanted to talk about today was I wanted to talk about a driven data competition question about earthquakes. And the thing is that this driven data competition question is an intermediate competition question according to their documentation. So it's not what I say, it's what they say. So I'd like to go over with you this intermediate competition question. And what I would like to do is talk to you about Catboost, because we use Catboost as the algorithm. And what Catboost says is Catboost is a machine learning algorithm that uses gradient boosting on decision trees. It is available as an open source library. And that's all I have on the actual Catboost. That's all I have on the actual Catboost. Catboost paperwork. Now, what I'm going to do at the description box down below, I'm going to leave you the link to GitHub for this program. And so that way you can go onto GitHub or Jupyter Notebook and go over the program with me if you want to. So the first thing we're going to do is we're going to talk about the problem statement. It says, based on aspects of building location and construction, your goal is to predict the level of damage to buildings caused by the 2015 Gorkha earthquake in Nepal. We're trying to predict the ordinal variable damage grade, which represents the level of damage to the building that was hit by the earthquake. There are 3 grades of damage. 1 is low damage, 2 is medium damage, and 3 is complete destruction. So you've got 1, 2, and 3. So what we're going to do is we're going to go over this program and what I did to solve the problem. The first thing that we have to do is we have to import the libraries. So I imported some of the libraries. There is actually a tutorial on the driven data for how to solve this problem, and so they had PathLab in here, so I put PathLab in there, but I didn't actually use it even though I put it in there. So in theory, I could have taken it out. The next thing we're going to do is we're going to read the files. These are the files that came with the competition question, so you can download them. And again, I had difficulty downloading them because I have a Chrome, but I was able to use a CSV viewer to view the files and then save them and download them onto GitHub. So these files are on GitHub. If you don't want to download the files, you can use the files that I downloaded and saved onto GitHub. So we check our train file, and the train file has loads of columns, but it doesn't have the damage column. So that's a problem. It doesn't have a damage column. So here's our info. We have a total of 39 columns, including the building ID, but no damage column. Now we check our labels. You notice that on train you have 86,868 rows, And now we're on labels. And label has 260,601 rows. So labels has a lot more rows than train does. And that is going to present a problem. And I'm going to tell you what I personally did to get around the problem. So you've got labels, you've got building ID and damage grade. So what they do on driven data is they don't put the target value in there with the train file, and as a result of that, you have to merge the two files together. And because the labels column has significantly more rows, almost 3 times as many rows as the train column, this presented a problem, and I'll tell you how I got around it. So this is something that I got from the tutorial, and it just tells you what the percentage is of 1, 2, and 3. So 1 was low damage, 2 was moderate damage, and 3 was complete destruction. So you see that very few buildings had low damage. Most of the buildings had moderate damage, and we'll say probably close to half of the buildings were completely destroyed. And so this is just a code I got from the tutorial, which I didn't do, by the way, but I'm going to do it when I finish this, and you'll find out at the end of the video. So now we check the test file. The test file has 868 rows, and it's got loads and loads of columns as well. But the first row is unnamed 0, and so what we have to do is we have to change the name of the first row of the test file from unnamed 0 to building ID. So that's what we have done. And now we check our sample file. This is the file format that Driven Data wants to see. I'd also like to say that Driven Data wants to see integers. Now what we have to do is we have to merge the labels with the train file, but the problem that you have is that the labels file and the train file are different links, and because they're different links, it's not merging very well, and we have a lot of null characters. So this is what I did. I spent all last night working on it, and I finally figured it at the end of the night when it was time for me to go to bed. So train with capital T equals PD merge, train labels, how equals outer. And then I did train with capital T, len labels, in colon. And so what we're seeing now is it goes all the way up to the length of labels, and then so that's what it's showing you. It's showing you everything from the length of end of the length of labels to the end of the program. So if I didn't put this code right here in it, then you would have had like 300 and something rows, because what it would have done is it would have added the 260600 to the 86868 to give you 347468. But I didn't want the label rows. I only wanted the train rows. And so that's what I had to do to get around it. And I spent all last night working on it. And that was the solution that I came up with to give you at the very end damage grade, because that's what we wanted. We want to attach the damage grade to the train file, but since the label file is so much bigger than the train file, we don't know what's supposed to go where. And so this is the solution that I personally came up with. If you've got a better solution and you want to leave it in the comment section down below, then certainly I will try it. So now what we want to do is we want to see, it's made a mistake. Now what we want to do is we want to see the damage. Let's just see here. We want to see damage grade equals train with capital T, damage grade, lin labels, colon, and then we want to see damage grade. So that's going to show you everything that is in damage grade. And now, train with a little t, damage grade, so we've created a new column now, equals damage grade dot values. And now you can see train, and we've got damage grade at the very end of that. So that was my solution to that problem. If you've got a better solution, if you know a better way to do it, then certainly let me know. Now what we do is we check for any null values, and in this instance, we didn't have any null values. And so what we have to do is we have to create a variable called ID test, and we're going to put test building ID in that variable called ID test, because what we're doing now is we're defining our X and Y variables. So Y equals train damage grade values, X equals train drop damage grade building ID axis equals 1, X test equals test drop building ID axis equals 1. And so since we are dropping building ID, we have to create a variable to put building ID in it before we drop it. So now you can see Y is in array because it's values. And now you can see X D type, and it's all objects and integers. And then you can see X test D type, and that's all objects and integers. And see, now what we're going to do is we're going to create a Kate features index, an NP where x.dtypes does not equals float. We didn't have any floats in there anyway, but that was the only way that I could get this to the model to work, because I borrowed this from somewhere else and I tried not to use it, but it wouldn't work if I didn't use it. Now we split our train data set up for training and validation. So we do stratify and shuffle and random state equals 1, and we check the shapes of all of our data frames. Now what we have to do is we have to install Catboost. So I've installed Catboost. And the next thing that we do is from Catboost, import pool Catboost Classifier CV, but really the only thing we need is Catboost Classifier. So model equals Catboost Classifier, eval metric equals accuracy, loss function equals multi-class because we're dealing with a multi-class, use best model equals true, random seed equals 1, fit X train, Y train, cat features equals Kate features index, eval set equals X val, Y val. So that was your model, and it says print X train, Y train. It went on for 15 minutes. And so it went on for 15 minutes, and I didn't get a really great score, but I kept running it anyway, because that's the name of the game, trying all these different algorithms out to see if you can improve your score. So we keep going. Our best score was 56.91%. Our best iteration was 488. So it was 56.8. Well, 56.9% really. And so now what we did was we predicted on the validation set, and we got a percentage of 56.9. So we had to flatten ypred. The only way that we could get this variable to fit into the data frame was to flatten ypred. So we created a data frame so you can compare the actual values against the predicted values. And one thing I'm not very comfortable with is all of the predicted values were 2. Now what we did was we made our predictions on the test set. We had to flatten the test. We had to flatten predictions to get it to go into the data frame. And then we also had to make predictions in integer because driven data would not accept it if it was not an integer. And I found that out. So with driven data, you're only allowed 3 submissions a day. So the first submission didn't accept it. So I don't know if that was one of my 3 submissions or not. But with driven data, you have to be very careful because they only let you submit 3 a day. So we made a data frame, and then what I wanted to do was I wanted to actually look at the data frame. So it gave you all 2s as an output. So I'm not very confident about the fact that it gave you all 2s as an output. And since driven data wanted an integer, what I did was I did the info command to make sure that both of the values were integer. So when I downloaded my submission file and submitted it to driven data, I got a 56.68, and my current rank is 890 out of 3563 competitors. So that means I'm within the top 25%. So that's it really. That's it really. So I don't think that Catboost worked as well as I would have liked for it to work, but that's the nature of trying out different algorithms and see which algorithm is going to work the best. So this concludes it for this presentation. If you like my presentation, please like, subscribe, and share.